In this tutorial, I'll show you how to convert a complex number from rectangular form to standard polar form. In all four of these examples, we have complex numbers that are in rectangular form. And all of these numbers take on the format z is equal to a plus bi. Notice that there are two terms here, an a term and a bi term, where I represents the square root of -1. Notice in this first example, a, we have z is equal to 5. It doesn't have the bi term. There's no imaginary unit here. We have to convert this so that it has the following format, where we have z is equal to a radius, and the radius has to be positive, so I'll put r in absolute, bracket cosine theta plus sine theta times I. Now, if we go ahead and multiply the radius into the two terms inside the parentheses, we get z is equal to r times cosine theta plus r times sine theta I. And I'm ignoring the absolute symbols just for the sake of simplicity. This suggests that this term is our a value and this term is our b value if you match it to the rectangular format. And in particular to our question, z is equal to 5, this means that a is 5. Let me write that down. 5 is equal to the right side, r times cosine theta. And here, I'll say 0, because we don't have a b term. 0 is equal to r sine theta. Focusing on this equation right here, what theta value, when you put it into sine, will ensure that the left side and the right side of this equation are 0. If you look at the sine wave, it looks like this, where it starts at 0 and 0, and it makes its way up, down, and then back to where it started. What theta value along the horizontal will give us an output of 0? Well, this one right here, and this one right here. So we have two options, theta being 0 and theta being pi. You have to select the one that will ensure that the radius is positive. How do we do that? Well, let's choose theta is equal to 0 as an example. If I were to substitute that into cosine, remember the cosine wave looks like this. If I were to substitute theta is equal to 0 into cosine, I would end up with an output that is equal to 1. Whereas if I were to input cosine at pi, then I would get an output y is equal to -1. And as a result, my radius would end up becoming -5. But you can't have negative radius. So the one that you choose has to be theta is equal to 0. So let me substitute that in case you can't see the bigger picture. R times cosine at 0 gives us r times 1 is equal to 5. Therefore, the radius is 5. So by choosing theta is equal to 0 as opposed to theta is equal to pi, you end up with a radius that is positive, and that's what we want. So writing this down in complex form, I get z is equal to 5 bracket cosine at an angle of 0 plus sine at an angle of 0 I. Okay, let's move on to b. In question b, we have z is equal to -3i. As you can see, we don't have an a term, so I'll say a is equal to r times cosine theta, and a has to be 0, so I'll write down 0 r cosine theta. And our b term is -3i. We can write down b is equal to r sine theta. I'll say b is -3, r sine theta. Looking at this equation, what theta value when I put it into cosine will ensure that the left side and the right side are equal? Remember, cosine will give us an output of 0 here and here. That is pi over 2, and that is 3 pi over 2. One of these will work. Which one is it? Well, let's keep our options open. Let's write them both down here. We can either choose pi over 2 or 3 pi over 2. Let's hypothetically choose pi over 2. If I were to choose pi over 2 and I placed it into there, sine at pi over 2 is equal to 1. So r sine at pi over 2 gives us r times 1, and that's negative 3. As you can see, the radius is negative 3 if we choose pi over 2, which is no good. But if we choose 3 pi over 2, so this being 3 pi over 2, I end up with the expression negative 3 is equal to r times negative 1, and only that will ensure an r value that's positive. So that's the angle that we choose. And the expression that we write in polar form is z is equal to our r value of 3, bracket, cosine, the angle is 3 pi over 2 plus sine 3 pi over 2 I. Now I'm going to give you an opportunity to figure out C and D. We have a video set up for C and D. If you need the answers, please leave us a comment below and we'll gladly upload it. Hope to hear from you soon.